Hi, this is Sam Welker with thinkparticle.com, and in this video we're going to be talking about the TP Toolkit Visual Documentation Series. You can find the TP Toolkit at thinkparticle.com, and if you haven't already gotten it. And it's a plugin for Cinema 4D that allows you to use thinking particles in ways that are more complicated, much quicker, without having to actually ever jump into Espresso. So to get started in this video, we're going to be talking about the TP Matter objects. That's plural. We have three different types of objects with which we can emit particles from the TP Matter node. So the first one is just the regular node. So we're going to go ahead and look at a few examples here, and then we're going to strip the scene and get started. So this is the TP Matter object, much like the TP Mograph emitter, but it's got a few different settings. Then we have the TP Matter light object, which is going to have the light affect the options. So you can have particles move towards the light or away from it. And then the last one is the TP Matter texture. And this is my favorite emitter out of all of the emitters we have, which allows you to emit particles from a texture. So in this case, we're just using a gradient. So we're going to go ahead and start by disabling those and go one by one and add them to the scene. So we're going to go to the TP Toolkit plugin, which can be found under your plugins menu. And we're going to start by adding the TP Matter objects, okay? All right, and we're going to move the light up, okay? So the TP Matter light object comes with an actual light. It isn't rendered. It is a utility light, which is used to calculate your thinking particle simulation. So, and you can't add another light in the place. I've tried to add that, and at the current build, we cannot change it to a different light, so you do have to use this light. But I can expand the settings on this light if anybody finds that for some reason this isn't enough, because again, it's not rendered. So the very first thing to do is add our thinking particle settings, or our thinking particle group. So that's a habit you're going to want to get into with the thinking particle toolkit. So go ahead and add the particle group, and the emitter enabled checkbox will allow you to enable or disable the emission of particles. Okay. Then you're going to want to set up your particle emitter, and in this case we're going to use a plane. And the TP Toolkit group right now is cloning cubes to those particles. So the next thing we're going to do is, something we can do is take the plane and get a selection of polygons and set that selection. And then we can control the emission of particles from that selection. So it will never emit from polygons that aren't under that selection. So a better way to visualize that is to crank this number way up. There you go. So you can now control your particles per second, again with the Mograph settings. So if you haven't already seen the TP Mograph video, go ahead and check that out. It's a different emitter, which we go into depth about the Mograph settings, but we'll just cover them very basically right now. You can control by checking this box right here and adding a Mograph object, like say the sound effector, or in this case we're going to use the random effector, and set the minimum value to 0, set it to turbulence, and turn the value down. And we can use that Mograph effector now with the affected slider to affect the settings that we have for our emitters and our particles. So the amount of particles we're emitting is being multiplied and jumping substantially. I don't know if you can see it right here. Maybe if we do this, it'll give you a better example. We have 1,500 particles per second. Now if we add the random effector, it's jumping up to roughly, I think, 10 times that actually. So that is the Mograph integration that is causing a variation in the particles that's going to give you a lot more control, like adding sound and Python and things like that. And it doesn't collect, or it doesn't affect each particle individually in the way that Mograph normally does. Like, you can't use the random effector to control each particle's position in this case with this setup, but you can control with the value put out by, say, the shader effector or the random effector, the amount of particles emitted and the lifespan and the Mograph, the speed. So those are different things that the Mograph integration will affect. So you can pick to emit on frame 0 until, say, frame 30. One moment. Excuse me. You can pick to emit when you start and end your emission. You can emit for just the first frame, or you can emit just for as long as your timeline will go. You can set the lifespan of a particle, and the lifespan, like we've talked about in the other emitters, is how long the particle will live for. And if you add variation to that, that particle will be born and then it will die within, in this case, 90 frames. So we're going to set that to 30. So each particle only lives for, in my case, a second. And then we have the variation, which says basically, hey, Mr. Particle, you have a lifespan of 30 frames, but because we have the variation, you only actually get to live for 2 frames. So he got gypped. Then you get another particle that has, say, 18 frames, but it won't go over 30 unless you add the Mograph affected value. That will push it up in this case. Again, that's a multiplier. So next we have our speed, and if we add speed variation, that's going to take the speed at which the particles travel, and then it's going to add variation. So some particles will travel at 0, and some will travel at 250 units in this case. And if we set that speed variation to 50, then some particles will travel at 125 units all the way up to 250, depending on the particle. It will be randomly selected. So we'll set both of those to 100. The next one is size. So if we clone our object, you can see that particles will come out, and the size will allow us to control the size of the particle, or in this case, the particles' objects, or the objects that are cloned to the particles. And we can add variation to those as well. So some will be big, and some will be small. So set that to 50, get a nice little variation there, and set the particle count to 150. All right, and then the distance is, this one's a fun one, so we're going to turn that off. Okay, we're going to go to the side view. Okay, particles are emitted from the plane. Now if we add a distance, that's going to set the distance from the actual polygons that the particles are emitted. Now if we add some variation, the particles will emit from that distance to that polygon. So basically, the particles are emitting up here down to here, and sometimes that gives you this nice little variation effect. So it'll be a little interesting. Some of the particles will start up here, and some will die down here. Up here, I mean. So that'll be interesting, but that distance allows you to, again, emit particles in different spots. So they will be born in different locations. Next is direction variation, and this is like the FOV values, but instead of having the X and Y axis control, you basically just have one axis, and it says we're going to emit with a 30-degree cone, or a 180-degree cone, or a 360-degree cone. So anyways, that is, or actually 180 degrees, it only caps there, I guess. So it will go 90 degrees in the positive and negative X and Z axis, and in the Y axis. And if we set it to 180, it will move in every direction. So that is how the TP matter object works. So next, let's go ahead and see how the light version, or the version with the light, is affected. So we have our particle group we need to set, and again, our particle emitter, and our selection, okay? Now particles are going to be emitted, but they're moving towards the light. And the reason for that is because particles will either act normally, and they will be emitted by the light. So let's go ahead and set the fall off to 100. and you'll notice that particles will be emitted from that light. So this is where it gets really exciting. Particles emitted from a light. Who thought? Who would have thunk? Super cool. And you can change the fall off to say linear, or you can change the fall off to step, which will give you a very hard edge. Inverse square clamped is going to give you a bit more of a soft fall off. Inverse square is going to be more physically accurate, or no fall off, and it'll just emit particles. But the closer ones will be bigger and emit faster and further. So as you can tell already, if you haven't noticed, the particle life and the particle count and the particle size and all of these things are emitted at their values set in the light, or in the emitter right here, only where the light is at 100% brightness on the ground. So right here, particles are emitted at the edge, but they're very far and few between, and they're very small, and they're very slow, and they die very quickly. But by the light where the brightness is, it's going to have a lot more particles come out. And they're going to be moving at their full speed, and their full life, and their full count of particles. And they can move in different directions, and have different variation applied to them. And you may notice that, again, there's another setting here, this percentage, and that applies to the direction variation. Okay? Or not the variation, the direction type. So we're going to move the light up. Alright, so the direction variation will cause that variation in the simulation. So if it's set to 0, the particles will all move towards the light in this case. But if it's set to 90, they're going to move a little bit more varied, but still towards the light. The next is the light reflection. And that will not be the direction of where the light goes, but where it comes from. So a great way to visualize this is go to the side view, and then we're going to grab the doodle tool. Yay, doodle tool. So say there's this polygon right here, and the light is hitting it from this angle and reflecting at that angle. Okay, so the particles are going to emit, and in this spot they're going to move that direction because that's the reflection of the light. But if they move towards the direction of the light, they're going to move towards the light. So that is how that works. So the next one, and the final one we're going to talk about, is the TP texture emitter. So we're going to get rid of the doodle. Lovely doodle, though. I love doodling. Beautiful doodles. So this is exactly like the light emitter. So we aren't going to go over anything besides just adding these right here. But the only difference is the textures. So natively, it's just like the TP matter emitter because we've set the birth texture to a plain white. But if we set it to a noise, you'll notice a lot of variation starts to happen. So we'll set it to wavy turbulence and turn the scale up and add some contrast. Maybe turn the scale up more. And we're going to turn the light off in the editor. So again, the particles are emitting based off of position. And, the particles are emitting based off of a texture. So in this case, we're going to render instances there. That should speed it up a bit. So we have this simulation coming out of these cubes right here. Let me just turn that off. Okay. These cubes are coming out because of the noise and the contrast at that point that's applied to this texture or to this emitter. That will that value between black and white, or 0 and 1, is being applied to the amount of particles birthed, the lifespan of the particles, the speed, the size, the distance at which they are emitted. So it takes these values in here and multiplies those numbers by these textures on the emitter, and then the direction as well. So you don't actually have any distance because we don't have any distance set. But we do, and we don't have any direction because we didn't set any direction variation. But that's how that works. So the particles are all currently matching this first texture. So the birth texture is the default. texture you'll edit. And if you want to add more control, all you have to do is uncheck these boxes. So in this case, the lifespan of a particle and the speed of a particle won't adjust based on that turbulence, but will just be constant because of that white. But we're going to change the lifespan and have particles die sooner just by matching that. Another thing we can do is the size. The size can be controlled by the noise, or we can control it by a different noise, or in this case, maybe a gradient. So that's kind of an interesting look right there. And we can go ahead and take that gradient and set the value from a 0.5 to a 1, or 90% to 100%. So take the brightness value, and that's basically your percentage controller. So in this case, it's 70% to 100%, and it's moving based off of the TP matter texture. And that is how that works. You can check these boxes or uncheck them to give them different control. If this box is checked, it's not going to take this shader it has right here, but take the one up above it. Okay, so that is the TP matter texture emitter, and the TP matters, because they matter, are fantastic emitters. I'm always very happy with them, and I hope you are too. They're very powerful, and you can create a lot of really cool, fantastic effects with them. We talked about enabling and disabling the emitter, the Mograph integration, adding particle groups, emitters, polygon selections, or point or edge selections as well. The particles per second, the Mograph integrations again, when to start and end the emission, the life spans and the variation added to that, speed and the variation, size and variation, distance and variation, and direction and variation, which I guess direction is variation. So thank you very much for watching this video in the TP Toolkit visual documentation series. I'm Sam Welker from thinkparticle.com, which is where you should go to find the TP Toolkit and get your copy and find the rest of this series. It's a really exciting tool, and we are still expanding it and upgrading it. If there's anything you're looking for, also make sure to let us know. We're always happy to expand and add more tools to the toolkit and update it so it is, so that it'll fit the customer's needs and our own needs. And go ahead and check out the rest of this series on thinkparticle.com. And again, I'm Sam Welker from thinkparticle.com, and I'll catch you guys later.